So I welcome you all. Okay, so yesterday I didn't introduce myself, so today I am going to. I am Aryan Mehra. Okay, I did my MSc from IIT Delhi, and now I am going to do my PhD from IISc Bangalore in the Department of Nanotechnology. Okay, and this is for those people who don't know me. Okay, and I started Physics by Aryan 2 years back. Okay, and this is our second batch which is going on. So this lecture series is about uh, solving the difficult topics of the syllabus. In last 2 years, I have realized that there are actually not entire syllabus is difficult, but some part of it is very difficult. And because of that part, students find IIT JAM and CSIR Net exams, these exams quite difficult. And there are some means there are some concepts if a student understands, then the entire topic become very easy. One of that is polarization. Okay. In entire polarization, when you study Malus law, or what is polarization, when you study Brewster's law, these kind of laws are easy to understand. Okay, but when you go to a mathematical portion, that how the circular waves are produced, how the elliptical polarization is produced, but what is the equation for plane polarized light, these kind of things are quite difficult. So we will touch that today. Okay, so number one thing is, which is very important in polarization, and it also comes under many names in different subjects, so it is equally useful for CSR Net. That is, what is superposition of two waves. I have written here two waves. Okay, the first thing which you need to always take care of when you see such waves, the one thing that should come into your mind is it is plane polarized. It is plane polarized wave. What do you mean by that? That electric field we are talking about has a one fixed direction, which is x cap. So electric field is along x cap. It is varying. Obviously, it is varying with time and distance, but it is always pointed along the x cap. So if I try to plot it, okay, let's say, so how I will do that? Like this. So it is oscillating in the x cap direction. So it is linearly polarized, or you can say plane polar. Plane polarized means it will always remain in a plane, and more specifically, it will always remain in a one line. So it is also called plane or line polarized, linearly polarized. Similarly, if I try to plot E2, which is along the y cap, so direction is fixed. Okay, direction is fixed. So it will always point towards y cap, either towards positive y cap, depending sign is positive or negative. Sign of this term is positive or negative. If it is negative, it will point towards negative y cap. And magnitude also depends upon what is the value of this thing. Okay, so it will kind of vary like this. Sometimes it will be here, sometimes it will be here. Okay, so this is called plane polarized. So whenever you see such equations, first thing that should come to your mind is it is plane polarized or linearly polarized equation. Your wave is plane polarized or linear polarized. Okay. So what is then circularly polarized and what is then elliptically polarized? In many times questions they ask you. Okay, they ask you. So what is circular polarized? Just by the concept, first understand that. So when you are looking in a plane, this is some kind of plane, let's say XY plane. Just to simplify, I am giving here X and Y. So XY plane. If your electric field is varying in time like this, okay, in time like this, then it is circularly polarized. It's very simple. If it is varying like this, it is elliptically polarized. Okay. These are the two polarization. Further in circular and elliptical polarized, there are two more things. One is left-handed circular, second is right-handed circular. Similarly, left-handed elliptical, right-handed elliptical. We will discuss in a bit that what is left-handed and what is right-handed. But right now you should know that this is. So what is the equation for these two things? Do we have equation? Definitely we do have. But what is that? So to answer that question, let's simplify it. So please write down one line in your notebook. In order to produce circular or elliptically polarized lights, we superimpose two plane polarized lights which are mutually perpendicular to each other. So I repeat my line. In order to produce circularly or elliptical or partially polarized light, we superimpose two linearly polarized lights which are mutually perpendicular to each other. So we have two linearly polarized lights and they are mutually perpendicular to each other. One is along x cap and another is along y cap. Very simple concept. They are mutually perpendicular to each other. So when we do superimpose each other, superimpose means on a screen on XY plane, which is your screen, you hit both these lights and see what is a net resultant. That is called superposition. So let's just superimpose them. So what do we do? We just do the vector sum. Okay. And if you do the vector sum, okay, x cap and E1, E20 sine kz plus omega t plus phi y cap. Now, the one thing which you should note here is in the first light and in second light, there is some phase difference, which is equals to phi. Phi is a phase difference between them. And depending upon this phi, we will have different kind of lights and we will just see how. First case which I have considered here is the phi is 2m pi. Okay, 2m pi, which means it can either be 0, it can be 2 pi, 4 pi, 4, and so on. So what will happen then? So this is our net electric field E. E is our net electric field. What is the x component of this net electric field? E1 sine kz plus omega t. And what is the y component of this net electric field? That is E20. And if I put phi equals to 2 pi 4 pi, so what do you think will I get there? Sine? What will I get? Tell me. If I put phi to m pi, what will I get here?
Sine kz plus
Sine.
omega t.
Sine kz plus omega t. So everybody agrees with that? Any confusion in this? I think this is class 12th thing. Okay. So now I have this one thing and I divide it. Now I need to see on XY plane how my net electric field is behaving. So let's just divide. If I divide EY by EX, what you will get? E20 by E10, which is nothing but just a constant. Okay, because E20 is constant, E10 is constant. So EY equals to alpha EX. Okay, EY equals to alpha EX. So can anybody tell me what is this? Is this the equation of line, circle, or ellipse?
Sir, line.
Line. So this is an equation of line. So it means if this is your screen, okay, and this is your net electric field, this is your EY, this is your EX, okay, then EY by EX, if you divide or you know the slope is alpha. Slope is alpha. Okay. So if this angle is theta, then tan theta is equals to alpha because slope is called tan theta and that is equals to alpha, which is constant. So your electric field must be like this. Net electric field must be like this if you want your EY and EX to obey this relationship. Very simple concept. So what is the first thing that we learned? If we superimpose two mutually perpendicular linearly polarized lights, which have a phase difference of 0, 2 pi, 4 pi, 6 pi, then you will get linearly polarized light itself. Okay, first thing which we learned. Second thing, now I am changing little bit. Now I am saying that the phase difference is pi, 3 pi, 5 pi. So very quickly, you know Ex will remain E10 sine of kz plus omega t. So I want someone to answer what will be E2 or Ey, sorry. What will be Ey? What will this thing become? If I put 3 pi, let's say, or pi.
Sir, minus E20 sine kz plus omega t.
Okay. Sorry, minus Ey. This is Ey. How many of you agree with the Shaunak Mishra? Do you agree? If you agree, say yes. Yes, it is right. So I understood. Or is this, I should do something else? You all agree? Say something. Yes, no, yes, no. So I know that class is a lie.
Yes, sir.
Yes, sir.
Yes.
Very
Yes,
good.
yes.
Perfect. Perfect. So now if I divide Ey by Ex, I get minus E20 by E10, which is minus alpha. Okay. And alpha is just a constant. So minus alpha Ex. Now tell me, is it an equation of line or not?
Yes, it is.
Still, it is a linearly polarized light, but now something has been changed. What has been changed? So in the same diagram, I will show so that you can understand. So this is your line. This is your electric field. Perfect. Agree? Do you agree?
Yes,
Yes, sir.
yes.
Perfect. So these is the two situations. So there are the thing which I learned is if the phase difference is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, if I superimpose two mutually, I am again and again saying mutually perpendicular linearly polarized lights, I will get as a result linearly polarized. Very fantastic concept. Now let's wrap it up by a final thing. Case 3. Case 3, your phi is 2m plus 1 pi by 2. It is a general form. You should also know how to write it in general terms. What it simply means is pi by 2, 3 pi by 2, 5 pi by 2, so on. So Ex again I am going to write E10 sine kz plus omega t. Ey is E20 sine kz plus omega t. Let's say pi by 2. So what should I write here?
Cos.
E20 cos kz plus omega t. Now you should not make a mistake of dividing it again. Like last two cases we used to divide. So what do we do now? So what you should do is first do Ex divided by E1 naught. You will get sine of, let's say there is something in here. And if you do Ey by E2 naught, you get cos of the same thing in between. So let's call it theta. What is theta? Theta is kz plus omega t. So if I square them and add them, so I am squaring them. So square, 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 square. So what will be on the right hand side? Sine square theta plus cos square theta, which will be 1. So I will get Ex by E10 square plus Ey by E20 square equals to 1. So now I want some intelligent person to answer that what is this equation? Ellipse, circle, what? Ellipse.
Ellipse. Ellipse.
So on the screen, what I get is ellipse. So I now very specifically want any girl. Okay, today girl participation is less. To answer that, what should I do to make this ellipse to be a circle? Can I do something? I will give you 10 seconds to think.
Constant equal to 1, sir.
Can you repeat what?
Constants are equal to 1.
Constants are equal to 1. No, they are not needed to be equal to 1. They just needed to be equal. So if E10 is equals to E20, then your equation will become EX square plus EY square equals to E1 naught square. So now tell me, what is this equation? Circular. Okay, circular. So this much I think almost all the books have this information, but it is quite difficult to comprehend it. So I think now you will have a better understanding of equations when you will study polarization. But our task is not over. Now we will do some questions, some random problems and add on problems to see if you can actually understand what I have taught.
भैया यहाँ पर सब लिसेजियस फिगर वाले केस बन रहे हैं.
No, you are wrong. So what is the difference between Lissajous figures and what we have been studying? There is one difference. Can you tell me?
Sir, Lissajous figures have different frequency, I think.
पर
Yes.
उसमें जब सेम फ्रीक्वेंसी के बनाते हैं तब ऐसे ही बनते हैं सब.
Lissajous figure is very general situation. Oh, sorry, very general. If you can change amplitudes, you can change frequencies. Okay, even in some situations, what you can do is you don't even consider mutually perpendicular. Sometimes it is in the same direction also. Okay, both are along x-axis. That also you got sometimes get. So Lissajous figure is a general situation. This type of situations are actually we see in nature when we study polarization. This is a, I will just explain you how the polarization can be obtained from this information. I'm just after the questions I will come on that, and then you will have a very better understanding of what is polarizers, what is wave plates, and so on. So let's say now I have first question for you is your E1 is 2 cos of kz plus omega t x cap, and your E2 is 2 sine of kz plus omega t y cap. So without doing any mathematics, can you tell me what will happen if I superimpose these two?
सर्कुलर.
It's a circular.
Circularly polarized. But the question number 2 which I want to have in your mind is either it is left circular or right circular. That is a question which comes in jam, or sometimes means even this question have come in jam many times, but now the additional question can also come. So how do we do that? So the very basic thing to undo that is with the help of diagram. With the help of diagram. So number one thing I want everybody to know that what is this diagram means. This diagram means this is a screen in which we are talking about XY plane. XY plane. This is XY plane in which we will plot the intensities, and this plane is at Z equals to 0. So if I plot Z equals to 0, so this is finished. Since we are talking about Z equals to 0, so we don't have to worry about KZ term. Only this term we need to worry about. So at t equals to 0, what is your electric field? Your E1 term is 0. Oh, sorry, your E2 term is 0. So your electric field, let me have the red pen. So your electric field is here at t equals to 0. Now at t equals to pi by 2 omega, this was at t equals to 0, and now pi by 2 omega, this will be 0. E1 will be 0. Why? Because inside it becomes pi by 2, cos pi by 2 is 0, and sin pi by 2 is 1, or you will get 2 here. So it become here. Now if you go to pi by omega, you will again have this. If you go to 2 pi by omega, you will again have this. So your circle is like this. The circle is anti-clockwise. But this much of information is not enough to tell either it is right circular or left circular. Then what is an additional information which we require? Now you have to see again we have to come back to plus kz term. Again come back to kz term. So now tell me, first thing, in which direction this wave is moving? In which direction the wave is moving? That you need to tell me.
In Z direction.
Z.
In Z direction. You understand by this kz. Perfect. So if it is moving along Z direction, it means it is coming out. What is Z direction? This is a Z direction, means coming out. If I imagine this blue dot which is coming out, okay, this is your Z direction. So now I have to point the right hand side or my thumb or my thumb, either of right thumb or left thumb, in the direction of this wave, in the propagation direction of this wave, that is along Z cap. And then I have to see, do I need my right hand or left hand in the direction of motion of this? So if you use your right hand in this situation and you put your right thumb in the direction of up incoming Z direction, and then you will see that your right hand fingers will also move in the anti-clockwise direction. But in this situation, if you do this the same thing with left hand, your fingers are moving clockwise, which is not our situation. Our situation is anti-clockwise. Motion is anti-clockwise. So you need to use your right hand to do that. So what is your polarization? Right hand circular polarization. Oh, sorry, right hand circular, RCP. Always remember, put your first thing is, so please write in your, sit in a way, electric field is coming towards you, okay. So if I said, if there was a situation that this wave is going towards negative Z, that is inside the plane, then you have to sit it in opposite direction, go in the opposite direction and then imagine. But in this situation it is coming out, so sit in a way that electric field is coming towards you, so Z direction is coming towards you. Then second thing, point thumb in direction of electric field and see which thumb, the fingers of which hand will have the same motion as the motion you have in the situation. So does everybody understood how to figure out what is right circular polarized and what is left circular polarized? How to actually do that?
Sir, can you please repeat?
Okay, so repetition is, first you need to, with the diagram you need to understand that either it is anti-clockwise motion or clockwise motion. So here we got anti-clockwise motion, anti-clockwise. Second thing is, you need to see in which direction wave is coming. So wave is coming along Z direction. Wave is coming along Z direction. Now you sit in the direction such that, like I am sitting in front of the screen. You are right now watching your laptop and Z direction is coming directly towards you. So you are in a perfect spot. You are sitting in a right spot. Now choose the thumb of either right hand thumb or left hand thumb. So if you choose right hand thumb and point it in the direction of plus Z, then you see your right hand fingers are also moving anti-clockwise. So it means your polarization is right circular pole. But if you do this with the left hand and point your left hand thumb in the direction of plus Z direction, then your fingers are moving in clockwise direction, which is not right. So it is not left circular polarized, it is right circular polarized. So does everybody understood what I have said?
Yes.
Okay. So this is a very big confusion. If you go to a Joy Gatak book, sometimes they say anti-clockwise means right circular or clockwise means left circular. But no, this is not a situation. The first line is very important. Sit in a way that electric field is first coming towards you, then see what is happening. Okay, very good. So with this knowledge, I think I will just give a pause of 10 seconds to, if you anybody have any question, then I have something in mind regarding polarization, which will give you actually a picture that how our polarizers and wave plates actually work and how we can make linear different polarized lights. So should we move if you don't have question? So
सर यहाँ पे वेव नेगेटिव z डायरेक्शन में नहीं जा रही?
यहाँ पे वेव नेगेटिव z डायरेक्शन में जा रही है. मतलब in this situation you are asking?
Yes sir.
So at plus kz. No. See, if we have omega t minus kz, then it is along positive z, है ना? If we have omega t plus kz, yes, you are right, है ना?
Yes.
So it is going along minus z. Omega t plus kz actually means it is along minus z. So I asked, some people said okay. So you can do that for that. If it is going towards minus z, let's say minus z. So now you have to sit in opposite direction. So when you do sit in opposite direction, you will actually notice that the motion is now not anti-clockwise, but the motion is actually clockwise. Just try to imagine if you sit in opposite plane of this. So what you will observe? You will observe that this is not actually anti-clockwise, this is clockwise, because if you go inside the mirror, this anti-clockwise will become clockwise. If you go to the opposite side and observe the same situation, so then this will become left circularly polarized. Okay, this will become left circularly polarized. Okay, so easiest way which I tell you is that whenever the question comes, always imagine, don't go in opposite direction, always sit where you are sitting, even if the wave is going in opposite direction, and find out which polarization is this. For example, in this situation we find out that it is right circularly polarized, but if the wave is going in opposite direction, then just reverse it. If you have found right circularly polarized, tick left circular polarized in question, your answer will be right. Don't get confused by going in the mirror and just imagining more and more. Don't imagine that. Imagine where you are sitting and imagine the wave is coming towards you and find the polarization. If in actual the wave is actually coming in that direction only, then you are correct. But if it is going in opposite direction, just reverse it. Like in this case, RCP will become LCP. So okay, so should we move ahead now? I have very nice topic in mind. So should we move? I just need 1, 2 yes or no. Then I will.
Yes, bhaiya. Yes.
Okay. So everybody learnt about polarizers. Everybody have studied what are polarizers. Maybe some of you have studied what are wave plates or retarder plates, like quarter wave plate or half wave plate. But what are these things actually, and how these things actually work? So that is a big question. To understand that, first thing you need to understand is in our universe there are some materials called anisotropic crystals. So first word to understand in this is crystal. Crystal is something in which there is a periodic arrangement of atoms. We all know crystal is something in which there is a periodic arrangement of atoms. Then what is anisotropic? Anisotropic means if you move in different directions inside the crystal, listen very carefully. If you move in a different direction inside a crystal, the atomic arrangement is different. It is absolutely periodic, but it is different. For example, let's say this is a crystal. some crystal, like say calcite crystal, which is a very famous crystal. If I move in this direction, the atomic arrangement is different. It is absolutely periodic and well defined, but it is different. But if I move in this direction, it is still periodic, but that arrangement is different. So for example, let's say in this direction there is first Na, then Cl, then Na, and then Cl, and so on. But if I move in this direction, the Cl is not in the straight line as Na, but like this, and then again Na, and then again Cl, and then again Na. So this kind of periodic arrangement is there. So if you see, both of these are periodic, both of these are well defined, but are different to each other. So what is the result of this? So if you are moving, or let's say you are a light and light is moving, so light will see a different kind of environment if it moves in this direction, and different kind of environment if it moves in this direction. So what is environment for the light? For light, environment is refractive index. For light, the environment is refractive index. For example, for us, environment is temperature. If I move in one side of the room, the temperature is different. If I move in different side of the room, then temperature is different. But for light, if it moves in one direction, it sees another refractive index. If the light moves in some other direction, it sees another refractive index. So the refractive index for the light moving inside the crystal is not same throughout the crystal, but it depends in which direction the light is moving inside the crystal. So these kind of crystals are called anisotropic crystals. Now these kind of crystals are extremely useful in making the different optical objects, optical instruments. For example, on what principle they behave, let's first understand. When you incident a plane polarized light, so let's say you have a plane polarized light on an isotropic crystal. So what will actually happen? It is little bit boring, but I think it is extremely important because the questions are directly coming through it from in the jam. So very important. That is why I have picked this topic, and it is very hard to read entire chapter for this. So if the plane polarized light is coming, let's say, or unpolarized lights, why linearly polarized? Let's say unpolarized light is coming. It will split into two rays in this crystal. One ray will go undeviated, and other ray will get a little bit refracted. Other ray will get little bit reflected. This will happen when unpolarized light will hit the anisotropic crystal. This ray we called it as ordinary ray or O ray. This ray is called E ray. Okay, I am not entirely making the notes or something, but I am just giving you, if you are very good in writing, or you can watch these lectures later, I am stating some properties of these rays. O rays are actually the normal rays and they obey Snell's law. What is Snell's law? The law of refraction. Okay, but E rays are extraordinary rays. They do not obey the Snell's law. They are kind of different kind of light waves. Okay, they do not obey Snell's law. They have their own, you can say, swag, and they do not. E rays are actually slower. They move slow than O rays in positive crystals. There are some materials also called negative crystals. We are not discussing about that, but in positive crystals, E ray have slow. So E rays are slow. So now you need to think about it. If one ray is slow and other ray is fast, so by the end they both will reach this place. What will happen? They will develop some phase difference between them. They will develop some phase difference between them. How? Let's say each ray has 7 waves. 7 waves, or whatever waves are these, number of these waves. Okay, so O ray reached here, but by this time E ray is still here. So there is a phase difference of this much. So after some time it will reach here, and this much extra will call as phase difference. So everybody understood? What will be the effect when we put our light? Okay, they will develop a phase difference. Now the second thing which you need to understand is inside crystals, both O ray and E ray are linearly polarized. So let's say you put unpolarized light, but once it gets split into O ray and E ray, both will become linearly polarized. So one gets polarized like this and other gets mutually polarized, means mutually perpendicular. So if one gets polarized along X cap, then other will get polarized along Y cap. Okay. So now do you think we have a very nice recipe? Both are mutually perpendicular and both are linearly polarized. And both also have some phase difference phi between them. So do you think the mathematics we studied above, we can use that to actually make circular and elliptical polarized lights? What do you think? Yes, no?
Yes, sir.
Yes.
How many of you understood yes, that yes, this recipe we can use here? Okay. Okay. So yeah. So now why first thing we got two mutually perpendicular linearly polarized light. Oh my god, this is very interesting. Then we also have phase difference phi. So what is the only requirement left? The only requirement left is we need
Phase difference.
to fix this phi. Okay, because this phi needs to be fixed. We need it to be according to ourselves. So how do we fix this? So it's a very simple mathematics. How do we fix this? So let's say NO is a refractive index for O ray. Okay, since O ray and E ray are moving in different directions, it means both will have the different refractive index because it is an anisotropic crystal. I just told you. Now NE is a refractive index for E ray. And let's say L is a length of this crystal. Now I want some person who have not answered yet, okay, to answer me that what is optical path length? If geometrical path length is L and the refractive index is N, then what is optical path length?
NL.
N into
N,
L.
N into L. Okay, if you don't know, you know now. If you so optical path length is actually considers the effect of refractive index in terms of path of the light. Okay, that is optical. If you uh, only consider optical path length, you don't have to worry about the refractive index variation or something. You just take optical path length, and that is actually geometrical path length, which is actually the distance between 2 points, and that is n. N is a refractive index of the material. So what is the difference in optical path length? Difference in optical path length of E ray and O ray. E ray एंड ओ रे के बीच का ऑप्टिकल पाथ लेंथ का डिफरेंस क्या है? सो व्हाट इज द पाथ लेंथ ऑफ ओ रे? इट इज NOL. And what is the optical path difference of E ray? It is NEL. So what is the difference? It is NE minus NO into L. NE minus NO into L. Now I want a answer, very concrete answer. If I want to make a quarter wave plate or simply a crystal which introduces a phase difference of lambda by 4, then my delta D must be, that path difference must be equals to lambda by 4, and I just need to equate both of this. lambda by 4. Lambda is a wavelength of the light. Ne and No we can know by doing some experiments, and L is the length of the crystal. So what you need to do is you just need to fix the length of the crystal if you want to change the phase difference phi between E ray and O ray. So choose your length in such a way that the phase difference between both are lambda by 4. Now why do we want to have a phase difference of lambda by 4? That is an interesting question. So if you have phase difference of lambda by 4, oh sorry, path difference of lambda by 4, what is the phase difference? Can anyone tell me?
Sir, pi by 2.
Pi by 2. Why? Because if you have a path difference of lambda, it means you have phase difference of 2 pi. So if you have lambda by 4, then you have to divide it 2 pi by 4. So that is pi by 2. So what happened when we had the path phase difference of pi by 2? What happened when we had the phase? We got elliptical or circularly polarized light. Am I right or wrong? When we had the phase difference of pi by 2, we got the either circular or elliptical, which depends upon कि E ray or O ray has same amplitude or different amplitude. If E ray and O ray has same amplitude, we will get circular. And if they don't have the same, we will get elliptical. So if I put my unpolarized light, or let's say linearly polarized light, on my quarter wave plate. What is quarter wave plate? Quarter wave plate is a crystal which introduces a phase difference of pi by 2 or path difference of lambda by 4 between E ray and O ray. Then the output will be elliptical or circularly polarized light. So how many of you understood this concept? Say yes or no. I think that will be much better. समझ आया? पता चला?
Yes, भैया.
Yes, sir.
Yeah.
Yes, भैया.
Yes, sir.
समझ? ओके, परफेक्ट. अगर समझ आया है,
एक क्वेश्चन था मेरा. हेलो.
हाँ पूछो, खुशी पूछो.
हाँ जी, वो ऑर्डिनरी रे और एक्स्ट्रा ऑर्डिनरी म्यूचुअली परपेंडिकुलर हैं, वो कैसे?
No. This is a path. This is a motion of O ray, and this is a motion of E ray. Polarization is mutually perpendicular. It means the electric field in this ray is moving in this plane. If let's say this is X plane, then the electric field in this will be propagating in Y plane. This is what I have said. They are not moving perpendicular to each other. Their polarization is perpendicular. The electric field inside these waves that are oscillating in perpendicular direction. You understood now?
हाँ जी. Okay, thank you.
Okay. Perfect. So now there is one more plate. Whenever you read the word quarter wave plate or half wave plate, these are called retarding plates, and how they work I have showed you. Okay, sometimes in JAM, in NAT questions, they have asked that if you have this length L, or no, sorry, they will give you NE and they will give you NO. They will say that you want to make a quarter wave plate, what should be the length of the crystal. They also give you wavelength. So this is a formula which you should apply. Now I want you to answer that if I want to make a half wave plate, what should be the formula? How should I change? Half wave plate means the phase difference, path difference must be lambda by 2. Half wave means wavelength ka half. So what should be the formula? Tell me.
Lambda by 2 आ जाएगा.
So Ne minus No into length of the crystal equals to lambda by 2. This is a formula. This is a formula. So lambda by 2 means the phase difference of pi by 2. And what will happen now? It's a very interesting question. So let's move back to the page where I first showed you. This is a page where we studied the 3 pi phase difference. So let's consider this is the plane polarized light which is hitting the crystal which is half wavelength, let's say. So what is happening here? This wave actually moved by this angle. And what is this angle? This angle is 2 theta. Okay, this angle is 2 theta. This is not, don't confuse with this theta. Okay, theta is this theta. So this is, if this is theta, then this entire angle is 2 theta. So when you hit a plane polarized light on a quarter wave plate, it still remains plane polarized. It do not become elliptically polarized or it do not become circularly polarized. It remains linearly polarized, but its plane of polarization gets rotated by amount 2 theta. So let's say this is a crystal. Okay, this is a crystal. So this is an axis of crystal and your light initially is making an angle theta. Initially is making an angle theta, linearly polarized light with this axis of crystal. When it will come out, it will still be linearly polarized, but in this direction. So the total rotation is 2 theta. Total rotation is 2 theta. So this is what the half wave plate will do. Okay. One last thing which is left is, in previous case, I didn't told you the situation in which it will be circular and elliptical. I told you, yes, I told you that when the EE and EO will be equal, it will be circular. But in which situation it will be equal? When your light will hit the crystal at an angle 45 degree, your circularly polarized condition will be satisfied. And when it will not hit at 45 but at some other angle, it will be elliptical. How? Very simple concept, very simple. So let's say this is the axis of your wave plate and this is your electric field, incoming electric field. Incoming electric field. Now it splits into two rays, one E, one O. So what is, and let's say this is theta. This is theta. And this has the wave, this has a, what you say, amplitude E. So what will be the amplitude of O ray? E cos theta. And what is the amplitude of E ray? E sin theta. So tell me in which situation these both will be equal. At what angle of theta?
45.
45.
5.
45. Perfect. That is a 45 is the only answer in which these, yes. So 45 is the only answer in which both of them will be equal. So let's summarize about wave plates. So wave plates, there are two kind of wave plates, quarter wave plate and half wave plate. We can also make different wave plates, but these two are famous. Wave plates works on the principle of double refraction. This entire thing is called double refraction. And anisotropic crystals are the materials which we use. The example of anisotropic crystal is calcite. Calcite. Okay, other examples you can also read from internet. Calcite. So in the calcite crystal, when a light incident, it splits the light into two rays. One is O ray, another is E ray. O rays goes undeviated in the straight line. E ray is little bit refracted. Both the rays are linearly polarized and they are mutually perpendicularly linearly polarized. If one is polarized along X, the other is polarized along Y. Now, by changing the length of this crystal, we can make it happen that what should be the phase difference between these two rays. The phase difference between two rays are introduced because both the rays have different speeds. Why they have different speeds? Because they see the different refractive index. Refractive index for both of them are different because it is an isotropic crystal. That is why the speeds are different. So speeds are different means they develop a phase difference. That phase difference we can decide or we can control by changing the length of the crystal. If we make the length in such a way that phase difference is lambda by 4, sorry, path difference is lambda by 4, we have quarter wave plate, and if path difference is such that it is lambda by 2, it is half wave plate. Quarter wave plate can be used to make elliptical or circularly polarized light. How? Just throw a linearly polarized light on a quarter wave plate at an angle of 45 degree with the axis of quarter wave plate, you will get circular. If you will throw it at some other angle, then you will get circularly polarized, oh sorry, elliptically polarized light. Second kind of polar wave plate is half wave plate. Now half wave plate also works on the same thing, but in this situation the linearly polarized light remains linearly polarized light, but it's the plane of polarization gets rotated by an angle of 2 theta. Okay, 2 theta, that is the only thing. Now I want to question you that this is a question which can be asked in the interview. How do you find the optical axis of the crystal? Let's say I give you a crystal. Okay, by just looking at the crystal you cannot tell that this is an optical axis of the crystal. How do you find that? So the very simple thing is, throw your linearly polarized light on the crystal and rotate the crystal. Okay, you will see an elliptically polarized light. Why? Because the angle between your light and the whatever the optical axis is not 45 degree. Okay, there will be one point, exact one point, where your elliptical polarized light will become circularly polarized. It means now your principal axis of the crystal and your light has a 45 degree angle. So at this moment you now know what is the principal axis. So if this is your light, then 45 degree away will be your principal axis, because now you know it is circularly polarized, the angle between them is 45. So everybody, do you understand today's lecture till here? So I think I will end the lecture here. So
Yes, Bhaiya.
okay, so now in the end I just want to show something to you. So let's go to JAM 2020 and optics. So I just want to tell one thing, that see these kind of notes I provide to every student who have taken our course. So these are the short notes. The whatever thing I have said today has been already mentioned in these notes. So if you are preparing for IIT JAM or CSIR Net exam and you want a short notes and the entire focus guidance PDFs, you should take the course. Okay, and in this I have the mission that no student should every student should go to IIT, and no student should have the argument that since the coachings are expensive we cannot afford it. Okay, and all these notes I have made for almost all the subjects. For optics I have already given the notes, interference, diffraction, and so on. So if you want to get the benefit, you should take the course. Okay, that's it. And last thing, please mention what are the topics you want to understand. Okay, if you find any topic hard, comment it in the group. I will see those comments and I will consider those explaining those topics also. Some of you have already told, and I think some of you have given me a good ideas about that lectures can also be made, because I also need to see that what are the topics actually you feel are tough. Two topics I definitely know, one is electromagnetism and one is classical mechanics. So those lectures will definitely come, but you also mention it, whatever the topic you think is difficult. Okay, so I hope today you learned. So, goodbye everyone. Let's me stop the